Hello, everybody. Welcome. Today we are going to talk about the power of the Civiv macros, and we will try to level up our coding with Civiv macros. So the main topic about the Civiv is it is actually evolving language, right? So this is the latest development from that language. So we will talk about what is the power of it. Let me introduce myself first. My name is Mustafa. As Yarun mentioned that I'm principal iOS engineer or mobile engineer, but when I sent this talk, actually I was principal engineer, but then I switched to dark side. So I'm engineering manager now, switched to the management level, but I'm still coding, working at Backbase. Last 6 years I'm working for Backbase. Originally I'm from Turkey, so yeah, I'm here with you today to talk about the Civiv macros. The first question, what are Civiv macros? So the Civiv macros are at a high level, the new language feature that allows us to write code that executes at compile time. What does it mean, compile time? When you try to run a code, your compiler, in this case it is Xcode, trying to compile your code and gives the successful result or the error. So in this case, we talk this compile time. With the macro power, we are able to add additions on that compile, so the compiler can use your code as well during that compile time. Even before compile time, you can see the error, validation, everything up front before hitting the run button. So this is the main power of Civiv macro. We will dive into it later on. This is introduced on Civiv 5.9, if I'm not mistaken, 2023. Before, actually, we were able to use Civiv macros by internally, but we were unable to expand them. We were unable to develop them. From 5.9 Civiv, we are able to develop our own macros as well. So we will see some examples based on that. And this can lead more safer, faster, and also reliable sources for us, and it will lead developers develop more safe environment in the code base because we are able to manipulate the compile time. And the next question is why Civiv macros? You can just think about that. This is your smart assistant for error-prone issues. It can prevent your errors. Also, we can use this as boilerplate generation. So that means if you have repetitive codes, that repetitive code can become a macro, and you can reuse during your coding, during your app development. And this is not only iOS specific, so you can use this also on macOS. This is also possible because you are actually building it multi-platform, so we will see as well. Actually, you were using this already in the Civiv development. Most probably you are familiar with preview, observable error, warning function, if debug. So those kind of macros actually being used by the developers already. And we are able to extend those on our coding level. So this will be custom now. And what are the key features of the Civiv macros? The first thing is compile time validation, and the next code generation. Also built-in safety check. That means your code will be checked by IDE for the safety reasons, and your code will be type safe as well. And the first thing that we can talk about the compile time validation. So when you write a code with a macros, your compiled macro will be validated compile time just before hitting the run. So your compiler will understand how it is working. It is correctly configured, or the syntax is correct. Everything will be validated first. then it will run the code. So that means you can get the warnings upfront before hitting the run button. So before your application goes to simulator, you see the error actually. So that means you are actually expanding the compiler. And the next is the code generation. So this is really nice case for us. So if you have repetitive codes in your code base, yesterday there was a talk using modular architecture, having your own modules. It was a nice presentation. So this is actually companion topic for it. You can use that boilerplate code generations with Swift macros. And you can make them as libraries. You can distribute them through Swift Package Manager. And then you can use directly on your app. So the repetitive code become a reusable stuff. So let's dive in some code. As Linus Torvalds said, talk is cheap, show me the code. So when you check your code, actually, your source code will be on like this left-hand side, the image source code. Macros will be expanded before hitting your compiler. Then it will be built. So the additional blue lines, your additional boilerplate code on macros, will be expanded just before building. So Swift will expand this and add the additional code in your code build. As I mentioned that you were using this actively already, like preview from the latest Swift UI. If you are developing Swift UI applications, actually you have preview macro, which wraps the content view, and then you magically see the content view on the canvas, right? But what happens if you expand the preview? Before macros, we were using make preview function, static function, and it was previewing our Swift UI string UI. Now with the macro, that macro will be expanded with the previous version again. So you will see the make preview, which is conforming preview from the developer tools. And the content view that you see on the top actually replaced here in the function. When you minimize this, you only see one line. When you expand this, you see the whole struct. Also, it adds available for iOS, macOS versions. Also, you see randomly named struct. So this is dynamic based on your project name and stuff. Also, additional information for the compiler, like static lets, column line, file ID, blah, blah. So these will be expanded just before your run, code generation. And then your compiler will use that code actually, not the macro line. So this is the actual code that is running by IDE. Another one actually you are using, or you might be starting using. So the top one, top class, it conforms observable object. On Swift UI, if you want to notify that value changes, like a name, age, location, if the value is changed, you have to publish them through combine. So the observable object makes it, and when you change it during the view model change, the published will announce, yes, there is a change, so notify this. Now you can use observable macro on the class level, and you can mark your class with observable macro. As you can see, it is much more readable, much more easy to understand. There is no published, there is no observable object conformation. Yet the idea is the same. It is working as expected, as the same way. What happens? The observable macro actually implements the same thing. Observable object here automatically marks name, age, location, or other properties by published. Then they are becoming automatically published. You don't change any code. The macro will apply everything to your code, and magically it will work behind the scenes. But on the readable level, you see pure class, no detailed or expanded code. And when you expand this, I mean the Swift expands this, it becomes again the same. So it becomes like a published, like a notified actually, not published, but you can get notifications if the value is changing. This is much more simple, much more readable. And now you can see that macros can conform protocols for you, conform views for you, or marks the properties, change the properties, getter setters. So we will see a deep dive. So these two examples that I showed were out-of-the-box Swift iOS or macOS features. And before Swift 5.9, as I said, it was internal we were using already. But now you are able to build your own packages on Swift macros. How? Xcode file new package. So you will create a new package and select the Swift macro. Then it will create something like this. How to create them part. On the left-hand side, you see the package name, my tools. There's a package class, which is SPM definition. You already know how to use SPM, so this is SPM. The rest are macro related. So my tools, the macro name, my tools client, and my tools macro. So if we check from the code side, on top, you are seeing one block, which is public macro some definition. This is under the my tools, the first Swift class that you see. So this is definition of macro. You can think about that. This is interface for the macro. There is no code block inside of it. It is just a sign. That's it. I will show in the next slide what are the things meaning. In this case, this is stringify. But there is no code block. So what makes it macro, or how do you expand the code? So the implementation is on the micro side, which is under my tools macro. And some magic code makes your macro works and extends the compiler. I will show them later on. And the last thing is using the micro. So the stringify a plus b gives you a tuple, and you should use this, where my tools client has a main string, main Swift. Main Swift will run this, so this is your playground. When you build a micro, under main, you can use this and test. So you will validate it is working or not, what is the problem, etc. By the way, this code comes out of the box directly when you create a micro. So this is an example code by Xcode and Swift. So I didn't write those. These are coming from IDE as an example. So you can modify this or write your own micro. So in this case, it is getting some data and returns that argument with some modification. In the implementation of micro, you will see expression micro is conformed to stringify micro, and you have to conform that function expansion. It has some functions, function parameters, node context, and expression syntax that is returning. So these are coming by conformance. So you're not writing those. These will be automatically be there. And the node parameter will carry all the arguments for your micro, like a plus b is your argument. And the context. So during that compile time validation, you can get some insights. So the context will carry those. And you do your magic, then you turn your code, and your code will be used by a compiler. So let's dive a little bit more. All the macros have categories. So it can be freestanding macro, or it can be attached macro. So on the top level, you are seeing freestanding, and on the bottom side, you are seeing attached. So both represents for category for your macro. You have two types. And in the parentheses, you are seeing the role, the expression on the top level. So freestanding is has an expression role, or the bottom side, the attached one has accessor. So this is the role. And the signature, as you can read the public micro, then the function type, like a how you define a function in Swift. It is the same. Stringify, some generic and value. So instead of function, you are using micro. The syntax is the same. But the return, you can define based on your need. And the equal side assigns the micros type. External micro, you have to mark your micros with external micro. It defines where is your actual micro, so the module, you are defining the module, and the type. So you can see that the name is inject, but actual struct will be auto inject micro. So I will access that code by inject name, but it will be finding the implementation under the auto inject micro under that module. So this is the definition of it. And what are those freestanding and attached macros? Freestanding, the proof is in the pudding. The name is freestanding, so you are not being attached to any member of your class. It is directly executable, directly usable. If we go to back, you see stringify is actually a freestanding macro. I'm directly executing this like a function and assigning the value and using it. So this is freestanding. You're not attaching this to any class, struct, or someplace. And attached, you have to attach that macro to some member, like to a class, to a struct, to a property, to a getter setter for someplace. So that's why the name is attached. And there are more roles. On the freestanding side, we have expression freestanding and declaration role of freestanding. And for attached, we have 5 more: peer, accessor, member attribute, member, and extension. So I will show the examples of them. And also you can see the marked signs. For freestanding, you are going to use hashtag, like a hashtag your micro, and @sign for the attached micros. Like just remember the observable micro. So it was attached. You are attaching it to the class. So that's why it has @sign. And remember from stringify, you are using hashtag, then it will execute it directly. So the expression one that we showed stringify, but what is the declaration? Expression directly executes like a function, you get the result, that's fine. For the declaration, you are declaring something, you are creating something, like a boilerplate, like a code generation. So if you want to generate some repetitive code, you are going to use freestanding or something attached, but yeah, we will dive into later on. So the declaration will generate that boilerplate for you. Only thing you have to do is marking that micro, that's it. So it will generate entire class, entire function based on your need. For the attached, we have more roles because you are attaching your micro to some member, a member of Swift. Are you going to attach that micro to a class or struct or something? Or its own members, like properties, like functions. That's why we have more. So let's show more code. On the expression level, we can use like a validation level, and then expression, I'm providing a URL and running my micro, like a validate URL name is up to you. It will validate that URL and it will return the response. So what we are going to do usually when you use a URL, you are actually unwrapping that URL, right? You are unable to use directly the URL. You have to make it like a guardlet. You have to be sure there's a URL. It should be validated, like maybe there's a white space in that, but you don't know. So something needs to be validated, then you can unwrap it. Micro can do this automatically just before you hit the run, and you can know it upfront instead of runtime crash or runtime bugs. So this can prevent those kind of things. And as I mentioned, for the declaration type, you can generate entire class or entire struct or entire function. So it's up to you for the code generation. So in this case, just plain and pretty basic. So you have a user model maybe, and that user model might create API request on the fly by micro. You don't have to create that class in your code base. That micro will create during the compile time, and you are able to use its own members, instances, everything you can use directly. So you can make it more generic. The fetch data might reserve for you any kind of code. It's up to you for the logic byte. So here you saw the class is generated, but what is the code behind the scenes of the micro itself? So again, the declaration micro. On top, you are seeing the definition, declaration micro itself, and it is an expansion function which we are confirming, right? So the first top part, guard-let argument, we are trying to validate the arguments are correct or not. So this is not micro code generation yet. This is just a validation. So we are validating if the arguments are expected, if they are null or not. So we are trying to understand that. And then the next part, you see like a bunch of strings. This is the boilerplate generation part. You see entire class is string, class something, then your init function, then your fetch data. So if you copy this code and use on Swift, it should be working. Then you can put the string here as a template. So this is the template part of my class. I'm unable to use directly class definition, like use this class as a template. This is not possible for now. But I can make a string literal and define all my class. So based on your logic, you can make the fetch data completely like conforming the concrete code, like a network logic. It's up to you. You can code this. Or initializers. You can make some generic code. You can use reflection. And during that reflection, you can make the parameters are dynamic, names are dynamic, everything should be dynamic. Then you don't have to use only these static strings. And when we have that class declaration, declaration syntax has string literal parameter, you are passing your class, and you are returning the generated class. So that means when you run that URL request micro, you will have this class. Immediately, you can use fetch data, you can get its init, but the class is not in your code base. So this is being created on the fly. But after the second line, after this create API request, you can reach a URL or its initializer. So this is the behind the scenes part of the declaration. Another example, I showed you like a URL validation, right? This is the code level of it. And this is expression micro. It shows under my tools micro, and the name is the concrete type implementation is under URL validation micro. And the function itself, the micro itself is validate URL. So if I put a valid URL, the let URL part has the unwrapped URL object. So you don't have to unwrap again. You don't need to use like a guard let, if let, something to control it. Because we are sure validate URL validates it correctly, then you can use the URL directly. So this will prevent a couple of lines. You will do all your checks. Then you will get the result. Let's say the URL is not correct. The domain is wrong. There's a white space. You don't expect HTTP, maybe. Or you have to put HTTP. So based on your logic, Xcode immediately show you your own error. So you will see, hey, the URL is not valid. So this is not coming from Xcode. I typed that error. Before I hit the run, I see this on Xcode. That means you can make this as a module. You can use that package all over your projects. And your rules will be applied immediately. The validation will be there. This is just a case of URL, but you can validate everything, right? So you are having some forms, emails, maybe empty strings or something needs to be prevented. So all the validation can be done immediately before hit run. And you can see that error on Xcode. So again, what is the behind the scenes? First top part, the same. Then my logic. So I'm getting the argument. What is my argument? The Google com that I showed. So I am trying to validate that URL based on my logic. So there's a function that I wrote is valid URL. Put your all conditions there. Then use that. If it's correct, return it. As you see, I'm unwrapping it already. So I'm 100% sure it is valid URL. Otherwise, I'm throwing a URL exception. Not exception, but error. Then Xcode actually shows that. So the error that you see here, hey, the URL is not valid, actually coming from that enumeration error, URL validation micro error, URL is not correct. So you can put any kind of errors there. There will be lots of validation errors for URL validation or other validation that you are working. So you will just throw them. And when you throw, Xcode will show it. So somewhere out there, I have my module. It is distributed. And I use that SPM package in my Swift UI project. And in the button, I have an action that validates the URL and directly uses that URL. But there's a white space in it. It immediately showed, hey, it is not possible, so fix it. We have a couple of use cases. So in the following examples, we will see attached, but I will not show for all of them for the behind the scenes because there are lots of logic. So you have to write that logic based on your need. To show that idea, I'm going to show how attached peer works or how attached member works, etc. So in this case, attached peer means you are using that micro for the peer objects. For instance, you have data fetcher class. There will be another peer of it for some other use case. In this case, my create mock micro will generate that mock data fetcher. And if I need a mock only for that class, I will just sign this with my micro, and it automatically generates that boilerplate code. And the fetch data will be mocked. So based on your backend logic, you can put any kind of JSON data or something. And the original one will execute as your logic. So yeah, that means entire class or struct will be used. So that's why it is peer. So we have more roles. The other one is accessor. Accessor means you can reach all the properties accessor functions. Like in this case, accessor blocks, not functions. Yeah. In this case, I need to log all my properties when you hit get, when you hit set. There is a use case. Just imagine that. So the logged property will update my code, and it will add print sentences inside of get and set. But this will be on the fly. You will not recognize this. So this can become immediately a logger based on your need. But on the code level, you will see only the plain version of it. There is no distracting code. You will only see the main code. But when you run the code, it will start printing immediately. So there was another use case for this. Print only in debug mode. So we are always debugging, right? So when you write a code, every minute that you're coding, you're debugging. So you don't have to put print cases, log cases. You can just say, use my logger, but only if print, then use the print. So if you reach that property, you will get the value that you want. So basically, we are reaching all the accessors, modifying the accessors, and based on your logic, you can add that code. From now on, if you notice that, micro only adding the code. It is not modifying any code. It is not removing any code. This is the main rule of micro. So this is additive feature. Only you can add code blocks. That's it. You are unable to modify, like change this name value. You cannot do this. Or you cannot remove set from here. It doesn't allow removing set here. It will only add some data. So that's why it is additive. It will only add boilerplates or the modification. So you might say, hey, I am adding print here, so my entire profile will be modified. We don't mean modification, adding some code. We mean by modification, changing the code's origin, like changing the name, changing the type, or changing the class name, like modifying the actual code. We cannot do this. But you can add some function, some code. It's up to you. Another one, the member attribute. Imagine that you have a situation that you have to apply for all your members. On the right-hand side, I'm trying to mark my features only available for iOS 15. For everything, I have to copy and paste, right? But I want to prevent this. Then I just wrote a micro, only iOS 15, that's it. So when I run this on the expanded level, all the properties will be accessed. All the members will have attributes. So I'm just adding attributes for my members. So in this case, Structs members are the properties. So I'm just adding the members. So based on the role, it is being changed. So that means with the member attribute, you cannot add a function here because its role is member attribute. You have to add an attribute for your member. That's it. It can add the attribute for function, for property, for everything, but only the member mark. That's it. So you cannot change the code block of the function. And the next one is member. So this time you can add another member. So in the first expression you have class person. It has name, age, something. Then you want to add more members in that class. So in this case, my auto description micro will add this var description, and it will have some logic behind it, like a mirror and stuff. It will get by reflection the names and properties. It will convert everything to description. So in my code, I will not see description, but when I run the code, you can use the description. So that means you can add members. So in this case, this is a computed property, but you can add another member, like a function, like a constructor. It's up to you. So it should be a member based on the role. And another use case, another role for extensions. Attached extension. Imagine that you have a case, there is a function you have to reuse for some extensions. You don't have to rewrite them each time. So this is a repetitive code, right? Like a log, log, log. But for int, for string, for struct, for date, I don't want to repeat that code again and again. What I'm going to do, I will mark my object or my members like a loggable micro. You see there is no log function inside of my structs, but on the code level, I can reach log function. So it will be running. So immediately it will be available. So struct log, int log, or date log, based on your logic, you can use the same function for different use cases. So in the first case, it will log some string. In the second one, it will log your value of int or the date. Maybe you want to refactor your date format. It will refactor it immediately. So you will see the data. So the idea is generating extension functions, so it will extend your members. Let's deep dive a little bit more. We have, I think, 9 minutes left. Yes. So in this use case, I'm going to show you an injection. So you want to inject your concrete classes, structs implementations to your protocols. That means you can run a micro. It can be accessor and attached, so you have to attach something. In this case, I'm going to access to the properties. That means my protocol will be injected by something. So the analytics protocol and network manager protocol will be injected with the actual implementation. So the dependency injection will be there. So my auto inject micro, again, the first things first, I will validate my declaration properties and also the arguments. So I will check if the bindings are correct, pattern is correct, the type is correct. These are just validation, no injection yet. So this is just the micro code starting. And the code follows like this. I'm going to inject my code, but how? I have like a really pretty simple code dependency container, which has shared instance. Then it will resolving somehow based on identifier and the type annotation. This is just looking for your registrations and returning the concrete class. That's it. And that code will be added to my getter. So here, I'm adding get function, get code block inside of that protocol. Then when you try to reach that get, actually it will run a dependency container shared resolved, and it will resolve immediately. When you hit run, it is resolved. So how I do it, I generate a body based on my statement, which is dependency container shared. And the accessor syntax has my body now. So when you reach get, you will reach body will reach initializer code, it will initialize everything and will give you the result version. Of course, the dependency injection is much more complicated. So this is just a logic. You can improve this. So this is not a final code. And what is my dependency container? It is just registering and resolving. So I'm just checking my shared instance, having registration and having resolve. That's it. So basically, my protocols will be registered here like this container register. Somewhere on the top level, you will register everything. Then on the app level, like maybe in your view model, you will reach that protocol, but without having concrete implementation. So that protocol will be resolved somehow. And that inject micro will do all the magic, and you don't have to resolve everything. It will do automatically. And based on your registration. Of course, if it's complex, then you have to check the types are correct, if it's assigning correctly. What if you register multiple times? So you have to think about those cases. But as I mentioned, this is just the logic of that implementation. That's all from my side. Thank you for joining my session. If you have any questions, I'm here.